folks, I want you to take a look at what I'm doing right here. I'm simulating a sunny, hot day in your house. And I've got a thermometer in your attic. And I've got a thermometer in your living room on the first floor. And what do you predict is going to happen? Okay, you think the attic's going to be warmer than the first floor. So in your kit, you get this box, and you have to tape it together. You sort of fold it up, and then use black tape, or any tape really on the inside if you want. So can I get a couple volunteers to come read off these temperatures for me? Okay, so could I get someone to write? Alan, would you be my writer? Okay, Christy's going to tell us the roof and the first floor temperatures right now.
The roof is 77.9 degrees Fahrenheit, and the floor is 74.5 degrees Fahrenheit.
So why is it warmer in the roof? There might be a couple reasons. It's closer to the light. The roof is definitely closer to the light. And what about the color of the roof? So what does a black roof do that a white roof or a shiny roof won't do? It absorbs the light and it converts it into thermal energy. Yeah. Okay, so it's going to convert that light energy into thermal energy because it absorbs all the frequencies of the light. It doesn't reflect them back. But at nighttime, when you turn the light off at night, doesn't your attic stay warm? What will a lot of kids say? A lot of kids are going to say heat rises. And then if the kid says heat rises, you can say, well, heat went sideways in that spoon. Heat can go any way it wants to as long as it's going from a hotter place to a colder place. Okay? Can you come tell us again what's going on with our temperatures? So we might have, like, every minute, we might take a look at what's going on.
Roof is 82.8 and floor is 74.8.
Wow, so big difference, 74.8. So if we were to graph this, Math Connection, we would see a bigger change in the roof than in the first floor, right? Now, caution, if you pull this too close or too long, it will start to smoke. Seriously, it will start to smoke. When I turn the light off, when the sun goes down and it's nighttime, what do you predict is going to happen to the temperatures of the air in the roof and the first floor? It will definitely cool some because the thermal energy will start to go from where it's warmer to where it's cooler. They might become, over time, they become more even. See what's going on here. Oh, it hasn't changed much. 84.7 up top, 75.2 down the bottom. So now I'm going to turn the light off. I'm going to set it down. And what do you predict is going to happen when I flip the house upside down? Now, this is when kids say heat rises. So it's closed on the bottom. I'm going to flip it upside down. And now I'm going to read off some temperatures to you. You ready? The top is now 76 and the bottom's 83. Now the top is 76.8 and the bottom is 81.7. Now the top is 77 and the bottom is 81.1. What's happening? Oh, someone said heat's rising. Heat can go sideways if it wants to. The top is 77.4 and the bottom is 80.4. So what's happening inside that house? What is inside the house? Air. So what's happening to the air? It's moving. Why is the air moving? It has to do with density. A lot of adults think hot air just naturally rises all by itself because that's what hot air does. That's not true. Hot air doesn't just rise because it wants to, because it's less dense. It gets pushed up by things that fall. So the cold air falls, and as the colder air falls, it was cold air here before, remember? As that cold air falls, it sinks to the bottom and it displaces that warm air that gets pushed up. Gravity is the force acting here. There's no magical buoyancy force that makes things rise. Helium balloons don't magically rise. They get pushed up by more dense fluids that are falling and displacing the air around them. You want one more reading? The top is now 77 and the bottom is now 77. What happened? So the air flipped around, and then it probably flipped around a little bit some more until it became equilibrium. So that is the step A to the house demo. Step B to the house demo is my favorite. What do you think would happen if I draped my roof with this? Here you can just buy it from the store. It's called an emergency blanket or Mylar wrapping around your Pop-Tarts. But what happens when I shine this on is it's not going to heat up my house. So Mylar is an amazing thing that it reflects the radiation, and it can prevent a lot of radiation from being absorbed into the house, which prevents the conduction with the air, which prevents a lot of the convection from happening. So radiative barriers might be something you'll think about for your little penguin house.